Hello everyone. Today we are going to discuss about total outlay method of measuring price elasticity of demand. There are different methods of measuring price elasticity of demand. They are total outlay method, point method, arc method, proportionate method, etc. However, in today's lecture video, I'm going to discuss about total outlay method. Okay, let's move forward. This method is also called total expenditure method, and it was developed by famous classical economist Professor Dr. Alfred Marshall. And this is an observation method. And in this method, the direction of change in total expenditure determines the value of price elasticity of demand. In other words, price elasticity of demand is measured by comparing total expenditure made by the consumer before and after the change in price of the commodity. We know that total outlay is price multiplied by the quantity purchased. Thus, TE is equals to P into Q. That is total expenditure. TE stands for total expenditure is equals to P stands for price per unit multiplied by Q stands for quantity demanded. As such, total expenditure may increase, decrease, or remain constant with the fall in price of the commodity. Let's discuss these three possibilities briefly. The first one is elasticity of demand greater than unity. Here, EP stands for price elasticity of demand, which is greater than 1. And in this case, price of the commodity falls and total expenditure increases. That is, there is inverse relationship between price and total expenditure. When total expenditure increases, okay, so total expenditure increases with the fall in price and vice versa. That means decreases, total expenditure decreases with the rise in price. So these two variables are moving in the opposite direction. Okay, price and total expenditure are moving in the opposite direction. So this is the case of EP is greater than 1, and it is also called elastic demand. Okay, this one is also called elastic demand. The next one is elasticity of demand equal to unity. In this case, total expenditure remains constant with the fall in price. So whatever be the change in price, whether the price is falling or rising, total expenditure remains constant. So there's no change in total expenditure. Okay. So when total expenditure remains constant or remain unchanged with the fall or rise in price, then it is said to be elasticity of demand equal to unity. And it is also called unitary elastic demand. In this case, total expenditure does not show any response. It remains constant. That means it doesn't show any response to the change in price. Okay, this is the second case. Now the next one is, the third case is elasticity of demand less than unity. In this case, total expenditure decreases with the fall in price and vice versa. That is, increases with the rise in price. Okay. So in this case, total expenditure decreases with the fall in price and vice versa. That is, increases, total expenditure increases with the rise in price. So there is positive relationship between the variables. That is total expenditure and price. Price and total expenditure move in the same direction. They are moving along the same direction. And this is the case of inelastic demand. That is, the value of price elasticity of demand is less than unity. Okay, let's move to the next slide. And this is the tabular representation of this concept of total outlay method. In the first case, you can see that there has been fall in price from $6 to $5. And because of this fall in price, total expenditure increases from $6 to $10. Okay. Okay, let me describe this one. In this first case, price falls and total expenditure increases because of this inverse or opposite relationship between price and total expenditure, as we discussed earlier. The value of EP is greater than 1. Greater than 1. Let me write this one. In the first case, fall in price from $6 to $5 causes the total expenditure to increase from $6 to $10. Look at the table. Initially, total expenditure is $6 multiplied by $1 is equals to $6. Okay, when price falls to $5, then the quantity demanded increases to 2 units. That's why the total expenditure is $10. Okay, in this way, fall in price causes increase in total expenditure, right? So this is the case of EP is greater than 1. The next case is, the second case is with the fall in price from $4 to $3, total expenditure remains constant. There's no change in total expenditure. Okay, no change in total expenditure with the fall in price. And this is the case of EP is equals to 1. Let's write this case. The second case, fall in price from $4 to $3 causes no change in total expenditure, and it remains constant at $12. The total expenditure does not show any response to the change in price. So this is the case of EP is equals to 1. And the last case is with a fall in price from $2 to $1, total expenditure also decreases from $10 to $6. Okay, so these two variables are moving along the same direction. And this is the third case where fall in price from $2 to $1 causes total expenditure to fall from $10 to $6. So these two variables, that means price and total expenditure are moving along the same direction. So this is the case of EP is less than 1, right? Now let me discuss these three possibilities or these three cases by the help of the diagram. So in the diagram or in the figure, total expenditure is measured along the x-axis and price along the y-axis. Now look at the figure. AB is the line which is downward sloping, and this downward sloping AB portion shows that there is inverse relationship between price and total expenditure. Price is falling and then total expenditure is increasing. So there has been movement from A to B, and this movement from A to B is called EP is greater than 1. So AB portion, which slopes downward, indicates that there is inverse relationship between price and total expenditure. The line is downward sloping, and this shows inverse relationship between price and total expenditure. That's why it is the case of AP is greater than unity. And the BC portion shows that there is fall in price, but no change in total expenditure. No change in total expenditure. That's why there has been movement from B to C, and this movement shows EP is equals to 1. The BC portion, which is parallel to y-axis, indicates that there is no change in total expenditure with the change in price. So it is the case of unitary elastic demand, that is EP is equals to 1. And finally, the last case, that is the third case. This is the case where price is falling and total expenditure is decreasing, and there has been movement from C to D, and this shows positive relationship between price and total expenditure. So it is the case of EP is less than 1. Okay, less than 1. So these are the three possibilities that this law, that is the total outlay method, shows. Okay. However, this method does not give us exact numerical value. It simply tells us whether the value of EP is equals to 1, greater than 1, or less than 1. It doesn't give us the exact numerical value. That's why if we need the exact numerical value, then this method is not applicable. We have to use another method. Thank you very much. Thank you for your time.